Hello guys. Yesterday, Spine 4.2 beta was released with the much awaited physics engine. It's nice to remember that it's still in beta, so it's like testing. Don't use it on production. It's mostly for you to explore the new features and everything else. They have some logs, change logs that you can find here on the initial screen, but the really improvement it was on the adding of the physics engine. So I created here a cute character for us to play with it, and I can show you how simple it is, and I will go through the parameters so you can learn what each parameter means and how it affects the physics. So let's go and explore it. I will make this available for you if you want to play as well. So after the tutorial is uploaded, I will make it available on probably on Spinimation website, so you can have access and play with it yourself. So it's very simple character. It's a furry jellyfish because why not? And it's two parts. The tentacle or the tail. I created one, but I will duplicate it so it looks like a jellyfish. But let's start with the very simple setup that we can do to create like very nice, beautiful physics animation. So what I did here, I have the root bone as usual. Let me make it invisible so we don't make any accidents. And then I created this another bone that I will use as a main controller, the center of the jellyfish. I will rig first the tail because it will be simpler, and for the head or the bubble, I have some nice tips for you and how to combine this with other constraints so you can create more interesting effects on it. So let's start by the tail. I will take my main control. It's important for you to know that if you are playing with physics and you have only like the regular bone, it will not work. You need a length, a bone with a length like this to make the physics works, because the physics it's more visible on the rotations. So I don't know. I'm just supposing. I don't know any technical aspects of it because it was just released few hours ago. I will check this technically if this is like a restriction or this is how it's supposed to be. But keep in mind the tests I did, it didn't work with the regular cross bone. So let me create a hierarchy here. I will create the full length. Then let's split it. Let's put it 5 maybe. Fibonacci nested. Okay, so we have like a regular chain of bones that are parented to the main control. Nothing special here. And they are linked. They are connected, right? So it's easy like that. You select all the bones you have and you go to the new, and you have this new constraint here, physics constraint. So you apply it. You see there is a new icon here that you can check. Let's rename it. Let's rename this main control. Let's change the color as well. Maybe green. Okay, so from here, it's working already. So if I move here, you see the bones are following. It's like magic. It's very interesting. Of course, you can animate everything, but by moving here, you can see already how nice it is. And now we will check the parameters for the bones. You go as you do with the other constraints, you click on the icon. Here you have how the transforms are affected, like offsets with the transforms for each bone. Let's make with the second bone so it will be more clear to you. If I change this, the translation, it will create like an offset from the pivot point when I move this. You see, that is the space here now. So you can do that with the other parameters if you want to play with it. I will not mess with this right now because the goal here is to explore the physics parameters. So I will close this, but feel free to explore this. I will close this and I will go parameter by parameter here. The first one that you have is inertia. Inertia controls like the dragging of the bone, how it resists to the movement that the main parent is doing. Like right now you can see it's very like heavy, and it looks heavy now. It's like there is some resistance happening here. So from the first bone, let's say I will put the inertia lower. It will be not affected at all if I bring it to the zero or close to zero, because the resistance now is very high. So if I bring this up to the top, it will be like the bone now is very light, so it's much more affected by what's happening on the parent. And this is what inertia is. So you can like create good effects. Like let's put this in the middle. Let's change the inertia for the other ones. Like let's make it more light as they go to the extreme. Let's make it more light. So you see what will happen here. You see now they are bending and rotating too much because they offers actually less resistance to the movement. Let's make it more resistant, because the right way to create the wave effect that you want is not by the inertia. So let's keep the inertia like 50 for everybody. It's a nice like standard value for everybody, so let's keep it 50. I changed this just to show you how it behaves. So next parameter is strength. Strength controls like the speed that the bone, you see when I drag the parent, the bone rotates and it goes like with an angle. The strength controls how quickly the bone will go back to the original position. So you see now it's very slow, like it rotates and it goes back like very slow. So by controlling the strength, we control how quick this will go back to the original position. If I put it this closer to zero, it will be much slower. You see? Now I have to wait a lot. It's like it's underwater. That is a good place for a jellyfish, but it's not the case. If I put this on the top, on the limit, the other extreme, it will go back very faster. So you can see by the main bone, because we didn't change the other bones, but we can do that now. Maybe to have a quick response to the movement is better in the case of this tail. So let's play with it, make it a little bit higher than what it is now. Let's see. Now it looks more natural. It still have weight, the sensation of the weight, but looks more natural. So moving on, we have damping. Damping is like the wave effect, because if I move it now, the bone moves and then go back to the original position. If I put damping on it, like if I bring it lower, it will create a wave effect. Instead of going to the original position, it will go after and go back and go after and go back until it gets to the zero position. Something like that. You see? Before it was just going back. Now it is like a spring effect. Let's bring it even more lower. You see? Now it's very, very evident. Of course, you have to find a good balance so you can have a nice animation happening. Let's put it on maybe close to 30. Let's see how it plays. Maybe it's good that we don't have too much damping on the start of the chain, the hierarchy, because this part is supposed to be heavier than the extremes, and then we can play with other values along the chain. Let's see how the effects will will be now with everyone. Actually, we don't have much. Very subtle. Let's see if we bring this lower a little bit. Yeah, it looks like the it's happening on the other ends, but it's not that evident. Maybe it is more evident, and looks like it. And for me, it doesn't look natural at all. So maybe keep this with less damping. It's a better choice. Maybe. So let's keep the damping high for the parts on the extreme. Because what you need to look when you are animating is if the movement looks natural. Even if it is like stylized movement, it needs to look more natural. In this case, that there is too much damping happening here. It's not natural. So even when I bring the value higher for this one to make it like a reset, having a larger dumping value here is still weird. So let's bring it back here, and let's bring this up again so we can have dumping, but we don't want this to be like too much. Like bring it a little bit lower. Let's bring this the strength a little bit as well. Yeah, because we can't forget it is a jellyfish, so the movement should be slower at some point. So we just need to figure out how to combine all the parameters. This one is really important, and this one will affect the chain in a more visual way because this is the mass of each bond. So here, that principle that the bonds are heavy on the top of the hierarchy and lighter at the end, this applies here. So let's keep this, let's put this a little bit up, and then let's bring it down along the chain. Let's keep this 100, and let's make this lighter a little bit, and also this a little bit, and let's see how it plays. You see they are now more, they make more sense. Let's play with this a little bit. Let's make it 100 again, so it's light, a little bit lighter. And let's bring this down a little bit as well. You can see the relationship with mass and the rest of the physics. Let's bring this very lower. If you combine when you are exploring the new features, if you combine the mass with the dumping, you can see how it works. Let me create another one here so you can see it happening. Let's make this physics. Okay, So you see it's happening now. Let's change the parameters here. Make the inertia a little bit high so it moves more, less resistance, and let's bring the damping down so you can see it dancing now even more. Yeah, now we can see, you see it's very light now. And if we bring the mass lower, it will be even more lighter. See, now it's very fast. It's happening very fast because the combination of damping and mass, they are kind of connected. So if I bring the mass, the standard is 100. If I bring the mass to like very high, you see this will slow the damping effect. Now it looks like a very heavy object because it makes sense. It has a mass of 400. It still has damping because it's like the inertia, the principle in the end by the books of physics is inertia. That means the dragging, the resistance to the movement, to the force. So playing with this two, it will give you more realistic simulation. So if I bring the mass down now, you see you would start the dumping effect to start more, you start playing more quickly. And it depends, of course, of the material that you are playing with. If on this bone you have like a very heavy metal ball, it makes sense it will be like slower dumping, you know. But if you have here something very light like a wood stick or something like that, it will play more like that because it's very light object material. So try to explore this, try to play with this, combining the parameters. And last but not least, we have the wind and the gravity. These are more like constants that are added to the simulation. So if I apply wind to this bone, it will just bring it to the right and to the left. So no matter how I play with my control here now, it's like the zero position that before it was like totally vertical. Now it has a constant that brings it to the right. It's like the wind is blowing from left to right. And let's bring it back here. And the same for the left, and the same for the gravity. It works like a constant. In this case, we will not notice because it is already like pushing down on the vertical, but it's kind of the same. You can bring it up or down. Let's see if it works here. If I create another bone here on the horizontal, let's apply the physics, and you see it will play. It has physics. So now if I play with the wind, I will not see anything happening because the wind operates on the left and right. But if I put the gravity here lower, it will push it up or push it down. And it works like the same. I can like have my physics still working, but like the rest position now is defined by the change that I did on my wind and on my gravity. So we will not need this bond. So I will leave like that. I think it's a nice setup. And next we have the mix parameter that you have on the other constraints. It just defines how much the whole setup affects the bond itself. So you can make it like 0 not affected at all, and 100% affected. So it works like the other constraint. So it doesn't make sense I stop to explore this. And of course, reset all, it will bring all the values to the standard. I will not do that because I like what I did here, and I will use that. All right. So last part is just mesh this. Let's use the trace, a little bit more vertices. I like to give it a little more padding. Not necessarily, but you know. And I like to do my vertex like symmetric to keep the polygons flowing. That makes more sense for me. I have explained this in other videos, that why I like to set up my meshes like this, to create like polygon flow, because I come from 3D. In 3D we have the same concept of triangles and meshes. So if you have a square, actually you have two polygons, there are two triangles. And on the 3D animation, if you have a flow with the triangles and the quads, it will create it will create better deformation actually. So that's why I keep the same principle on spine, and usually it works very well, because in the end they are all triangles. So I try to keep it symmetric, like the same vertex on both sides. So the deformation follows logic. That's why I don't like floating vertex along the mesh. And I like to use this feature to create like structures and preserve the tails on the image that I'm using. So this is a very quick but very useful tip. Maybe I am thinking to record a tutorial about meshes, how I think about meshes. Maybe it's not the same way that other animators used to do, but for me it works very well. Okay, but this is something that is coming in the future. Okay, let's keep it like that and see how it plays. I will put my tail slot under my main control, and I will bind the bones now. Let's put it here, 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 and here. Okay, let's check how it is. Maybe some smoothing will help. And all right, I guess this is it. And now I have my tail. Okay. What I will do now, I will duplicate this setup so I can have more tentacles, but I want to keep my main control. So what I will do here is create like another route for this chain. Maybe I can change the icon here. Square is nice. And then I will parent this again. Instead of the main control, I will parent to my new route here, and then I can put it anywhere. So I will duplicate it now. Let's call this first tail root. We'll duplicate it now. So oh, it loses the oh my god, I didn't know that. So this is not nice. Actually, I need this tail to be inside the tail root. It's bad that's not keeping the constraints, like duplicating it. It would be nice, but we can like create like a standard setup. We will not do everything again, but if we just apply the physics here, we have then working with physics. This one is exactly the way I want. This is not, but just for the matter of the tutorial, I will not waste your time going through all the setup again. So let's duplicate it again. So we have three, at least three, or we can make the scale of this one a little bit smaller, and then we can bring it back to the back. All right, and maybe we can make it darker because it's on the back part. Oh yeah, and let's duplicate it again so we can have like 4. All right, let's create again the constraints, physics constraints. All right. Okay, now we have a lot of tails. And the last part, actually, let's this bothers me. They are moving exactly the same. So let's just change one parameter here. Let's make the inertia a little bit, and let's make the mass a little bit. Okay, that's fine. The bubble. The bubble, I would like to create a bubble effect. We can do that in many ways, but let's keep the physics happening. So I will create another one here, but I will not use this as the binding bone. Like I will not bind the mesh to this bone. I want this to have physics because I want the bubble effect happening like dynamically. Let's play with this here. Last string. Less mass because I want it very bubbly. Yeah, like that, you see? And then you have different weights happening everywhere. What I will do here, I want this mesh. Let's make it a mesh already. Let's create internally. Let's create a circle. And maybe another circle inside. Just to have like more control over the bubbles. Okay, so this will be the mesh, and the bone that I want to drive this, I will put this inside the main control, of course. Oops, always filter, then go to parameter, the parent, sorry, and then make this the parent. So now I have my main control with the bubble inside. This one, let's call it bubble physics, because it will drive the physics, but it will not drive the deformation. So for this, I will create another bone here, and I will put it on the center. Let's make it the traditional. And now I will create a transform constraint to this bone. So you can combine constraints. This will be the bubble effect. Let's call it effect. And of course, you can combine all of them, I guess. But I will play with the translation for now. What I want to do here, if I play this now, of course, it is on 0 here. I want to have more horizontal movement than vertical movement, so I will put this like 100. I'll put this like 30. Yeah, so maybe it's too much. I want to create an offset. So let's make it like 60, and let's make this 10. Okay. So this is a way you can like refine how much of the effects that you want. But to refine this, maybe it's better now that we bind the bone to the mesh. So I'll bind this bone only. No, I'll bind this too. The main control that will hold my vertices and the bubble effect that will distort my mesh. So if I check now how it is, that's not how I want it. I want like the main control. Let's make it 100% on everything else. Let's make this weight. Oops. And now we can start doing like more precise setups here for the weights. So for the outer part, let's make it like a 50%. And for the center part, let's make it like this, 3/4. And now if I play with it, there is a bubble effect in the middle happening. Of course, right now, my main control is holding 100% of the edges. I don't want that. Maybe for the lower part, I want it more in place, but for this part, I can make it more. Let's control the center here. I want to make it more bubbly. So let's put a quarter here and see how it plays. And let's play again with the values here, maybe more vertical. Let's put 40 and see how it plays. Oops, sorry. 60 and 40. Actually, we need more vertical. Let's make it very big, because the vertical information that it's getting here is from this bone. This bone is not going up and down, but the rotation is. So if this bone is attached on this position on along the length of the parent bone, the vertical that we'll have, it will be like related to the angle of the bone. So if the bone is at this angle, this bone here, it will be not like here, but like here. So the vertical here is much has much less influence because of it's getting the height on the rotation. So what we can do is make it higher than the horizontal, because the horizontal is very clear, it's going left and right here when I move it. So let's see how it plays now. Now I have more vertical, you see? I have more vertical actually when it goes on the extremes, because when I go to the extremes, this bone here, it goes more up and down. So another way to control this is to change the physics again, or make it more damply, or make it more lighter. So it will, if it's more light, it will swing more. But I keep saying dumpling, like the food, but it's dumping. The dumping here, maybe I should keep the dumping lower, because the dumping is affecting the speed of the swing effect. So let's bring the dumping a little high, and let's keep the mass lower, less resistance. Let's see how it plays. No, actually, I make the wrong one here. Less is lower, so I need less resistance. No, it's the opposite. You see, it's a little bit confusing. So let's make this high. Let's bring the damping back. The inertia. Yeah, but this is a very simple setup. It's one bond connected to one constraint, transform constraint to one physics bond. You can play however you want. You can create more bonds here with more physics and create like reactions for the tip of the base. I will not spend time with this because this is what I want to show you actually. How the physics played, how you can combine it with other constraints. Of course, we can always bring this up. It will increase the bubble effect for sure. Overall, you can put it more precisely on parts that you want, as you know it. Oops. Yep. And of course, it won't be a good tutorial if we don't have animation. So let's animate it. Let's make a 30-second animation. Let's bring it here. Let's put it here. Which is nice is that sometimes I don't know if it will work here, but sometimes you don't even need to loop your animation because the physics can do it by itself. You see, I'm playing the loop. I just set up the loop for the main control, and the physics are playing along the loop. They are looping by itself. So this is pretty amazing. Let's add some rotation here, but let's first separate the translations so we can play with this here. So it's not like just horizontal. Let's bring it up a little bit. So I have a more elliptical movement here. We can make it more pronounce it. Of course, always check the curves on the loops. Yes, like this. And let's add the rotations. So coming from here, I want thing intentionally going there and going back here. And of course, we need to polish and isolate them. You can play here, and it works very fine manually. Not beautiful. Let's make it more here. Okay, so now it's more smooth and nice. Yeah, this is it. Very nice update. Enjoy this time of the beta. Remember to not use it on production. And have fun with physics. I hope you like it. I will make this available for you so you can download it from spinimation.com. I am creating the courses right now. There will be a course about animation itself, the principles. I have a kind of different approach to the principles of animation, not that like 10 commandments or going one by one. I want to teach you like physics, like this release, how physics works with the motion and how you can apply that to create intention on your characters or objects. So it will be a very nice course. It's very different from every tutorial you have seen so far. So keep your eyes open for that. This is the main course, the big one. So it will take more time. But I know some people want to learn more about more specific stuff. That's why I'm creating the courses for splash art, for motion graphics and motion comics, as they say, 2.5D animation, whatever you call it. And the lip sync and walk cycles and things that are more specifics. Of course, it will be less expensive courses, accessible to everybody, because what I really want to do with spine animation project is to teach you animation. So I am keeping the really good stuff about animation to this one, to this course that I will call it Power Up, because it is like a power up. So I hope you like the tutorial. If you are not subscribed, it's free. Go to spineanimation.com, subscribe please. You can find me around social networks, Instagram. I am more active. You can drop me a message there anytime. You can find me on YouTube, of course. Sometimes I am on Twitch. So I am all around LinkedIn and X, or Twitter if you prefer. Uh, just ping me there and we can have a chat, and maybe I can help you with something. All right. Thank you for watching and see you soon.